make this guy big. So last time we talked about the SearchStreamGang program and its various implementation strategies. I gave you an overview of the driver program, the SearchStreamGang test program. We took a look at some of the abstract superclasses like SearchGang and the various, StreamGang and SearchStreamGang and so on. And then we looked at the implementation of the sequential search with loops code. And we talked about how that was efficient, but the downside was that it used all these classic Java control constructs like loops and used things like if statements and so on. And there were some deficiencies there because you had to remember to allocate various variables like array lists, and it just made it more complicated than we might want. So what I'm going to do now is I'm going to kind of walk through the search with sequential streams implementation strategy in order to compare and contrast a way that avoids the use of these control constructs. You'll see there's no loops, there's no if statements and so on, and instead we replace all this with various functional programming features, lambda expressions, method references, and of course the streams, intermediate and terminal operations, and we'll take a look at some of them. These are also things that have been covered in other videos. So search with sequential streams extends SearchStreamGang, so it inherits a bunch of the methods there, and we have a constructor, and the constructor basically calls up to the superclass, and the superclass stashes away the phrases to find and the iterator that we're going to be using and so on. And so let's take a look at the interesting methods. That's not very interesting, that's kind of bookkeeping. So the entry point into all the different implementation strategies, as you may recall from last discussions, is process stream. And what we're going to do here is we're going to get the input, and the input here is going to be all the complete works of Shakespeare as a list of character sequences. And we use character sequences again because they are much easier to subset or subsequence without having to do unnecessary memory copies. Unfortunately, when you do a substring, that ends up doing a lot more memory copying than we might want, or we do want, for some of the things we'll talk about later, having to do with splitterators and so on. So we have this list of character sequences we call the input list, and now we're going to use streams. So remember before what we had done, just to clarify what we had done before in the process stream method, we had to make a new array, and we had to have a for each loop, and we had to add something to the array when we call process input and so on. And no longer will we have any control constructs in the classic way of having control constructs in C, C++, Java, and so on. So we take the input list, which is this list of character sequences, we turn it into a stream of character sequences, and then for each of the elements in that stream, which again, each one represents a work of Shakespeare, we're going to call the map intermediate operation. And map is a method that takes an input stream, and for every element in the input stream, it's going to call a so-called mapping function to do some processing on that element. In this case, it's actually going to transform it. You don't have to transform it. In this case, we do transform it. And for every element in the input stream, map will call the mapping function, which in this case is the process input method reference that we'll look at in a moment. And the output stream that comes back from map will have as many elements in the output stream as there were elements in the input stream. Unless, of course, an exception that's not caught is thrown. But we'll pretend like that doesn't happen for the purposes of this discussion. We'll take a look at process input in just a second. What we have now is a stream of so-called search results, and we're going to go ahead and collect all those search results into a list. And this, of course, is using the collect terminal operation. When you watch the videos, you'll find that there's different kinds of operations in a stream. There's intermediate operations, things like map and filter and so on. And then there are terminal operations like collect or reduce. You can always distinguish between a terminal operation and an intermediate operation because an intermediate operation is going to return a stream, whereas a terminal operation will not return a stream. So by design, terminal operations don't return streams. So in this particular case, we're going to collect it, and we're going to collect it using something called the toListFactor method, which comes out of the collectors class. And you can see that toList goes ahead and creates a new collector using a special helper class that's private to the JDK, the Java class library, called collect constructor impl, and it basically will make a new array list, passes a constructor reference to make an array list, which is called the mutable result container. We pass in a method reference to the list add method, which is used to add the next item to the array list. If we're doing parallel streams, which we're not, but if we were, this would be what's called the combiner, and it basically adds one list to the end of the other and returns the original list. And then the other thing here is something that's called the characteristics identity finisher, and we'll talk more about all these things later. Don't have to worry about what they do, but the point of this is that there's a factor method that's defined that creates a list collector that will return a list. And what we have here as return is a list of search results. And we'll see in a second why it's a list of search results. To understand why it's a list of search results, we have to go down and look at process input. So process input is the method reference that's passed to the map method. It's defined just a few inches down in this file. And what process input does is it takes an input sequence, a character sequence that corresponds to a given work of Shakespeare, like Hamlet or Macbeth or Twelfth Night or Julius Caesar or whatnot. And then it goes ahead and it basically does processing to search that work of Shakespeare for all the phrases we're trying to find. So the first thing it does is it goes ahead and it splits off the title from the work of Shakespeare. And this is just a really clever regular expression pattern that finds the title, which always appears first on the first line. So it goes ahead and returns the title of the work, the title being, The Tragedy of Hamlet, or Hamlet, the Tragedy of Denmark, or whatever it's called. And then here's where we use subsequence. We take the input sequence and we skip over the length of the title, which is what we got from the getTitle method. And then we make a new subsequence, which is just the part that consists of the actual text of the play after stripping the title off. So this is actually the play contents itself. And then we come down here and we take the phrases to find list, because we had passed that in before, and we convert the list of phrases to find into a stream of phrases to find by using the stream factor method, in this case, the sequential stream factor method. And then for each of the different phrases we're going to look for, we're going to use the search for phrase method to look for the phrase in the input. And we pass a few other things in here just kind of for bookkeeping, the title that we're looking at. And in this case, we pass the parameter that says false, and I'll talk about that more in a second. Now, this particular search for phrase method is called in the context of the map intermediate operation. And again, what map does is it's going to take a stream of phrases and it's going to go search for each phrase in the input. And what it returns is a stream of search results. And you can actually see that here with the IDE being nice and telling us, oh, this is a stream of search results. So the stream of search results will consist of whatever we found, if anything, in the input work that match the phrase we're looking for. And as you can see here, we may not have found anything. If we're looking up neither a borrower nor a lender be in Julius Caesar, we're not likely to find that phrase because it doesn't appear there. So what will happen is that the search result object we get back from map will be empty. So we're going to filter out anything that's empty. So anything that's empty gets ignored. And there's different ways to do this. This is using a little negator method I wrote. You could also say, filter result arrow result.size greater than 0. You could say filter and cast this thing to a predicate and call the negate method. There's all kinds of things you can do. I just like this particular format. And what that'll do is that'll mean that when we go to terminate the stream with the collect operation, if there's nothing there, we'll get back an empty stream. So what we're getting here will be these search results, and what we have, we collect this into a list of search results. Now it might be a list of empty search results, and if none of the things match, and there's other parts of the code we'll look at later that's used to get rid of the emptiness, and the way it's done, just to give you a preview of coming attractions, is that these things, empty lists, are filtered out by the flat map method, which is used for several purposes, not the least of which is to get rid of empty stuff. So if you try to flat map a bunch of empty lists, they just get swallowed up by flat map, so they disappear altogether. I want to focus on one more thing here, though, which is the search for phrase method. Now, this is actually something that's defined in the SearchStreamGang superclass. and it is something we didn't talk about last time because I was only focusing on the parts that were relevant for the loop-based version, which had its own implementation of this. But here's search for phrase. And search for phrase, as you can see, is going to be used to look up for all the instances of the phrase, to thine own self be true, or my kingdom for a horse, or whatever your favorite bard phrase is. It's going to go look that up in this input character sequence. And this parameter here that says parallel controls whether the search is done in parallel or sequentially. Since this particular code here is the sequential version of all this stuff, we're passing in false so that it doesn't try to do parallel search. We'll come back later in the course when we've talked about parallel streams, and we'll talk about how you can do the parallel version of all this stuff. So what we do here, this is really, really cool, is we go ahead and we call a helper class method called StreamSupport.Stream, which is a factory method that takes a split iterator and a Boolean parameter, which in this case will be false because we're just going to do a sequential stream. And it will go ahead and create a stream that will take the output of the split iterator. And what the split iterator is going to do here is it's going to go ahead and create a stream of result objects that record the indices, if any, where the phrase matched in the input string. So again, if we're looking up, a very common Shakespeare word, anon, which means immediately. If you look up anon, you'll get a gazillion matches of anon. He loved anon for some reason. And so phrase match split iterators we'll see is going to be the workhorse that will go and search that string to find all the places where anon might have occurred. Now what we get back here is a stream of result objects that correspond to what matched, and we collect that stream into a list. So we have a list of search results.result objects, and then we're going to tack that at the end of this class called search results. And search results is what keeps track of the results of doing a search, and it keeps track of what phrase we're looking for, what the play occurred in, and other sort of metadata information that we need for printing output later. So the last thing I'm going to show you real quick, and this is just a teaser for things we'll cover in more detail later, is the phrase match split iterator. And the phrase match split iterator is used in order to be able to take, in this case, the input of the play and the phrase and see if there's any matches in there. And it does it in a super duper clever way by using regular expressions. I won't go through all the gory details of this. There's a whole lesson about this that we'll cover later. But basically it takes the phrase and it makes it a regular expression, and it compiles it to do case insensitive searches that can span multiple lines. That's what all this stuff is doing down here. And then we create what's called a pattern matcher, where we take this regular expression that we created and we connect it to the input, the work of Shakespeare that we're trying to search. So that's where everything starts. And then the streams framework, which gets kicked off by that StreamSupport.Stream call that we had looked at over here. Let's see. Here we go. So this call here, StreamSupport.Stream, this is going to kick off all the processing we're seeing here. And it's going to internally, the framework, the streams framework, will keep calling this try advance method over and over again until it finally returns false. And try advance is kind of the sequential workhorse of the split iterator framework, which we'll talk again about more in later detail. And what we do is we come in and we check to see, is there a match? Is there a regular expression match for that phrase left in the string? That's what that's asking. And if the answer is no, then we're done. We return false. The framework says, uncle, I'm finished, and it returns whatever it's computed at that point, which could be nothing. Otherwise, we found a match, so we go ahead and figure out where that match occurred, what index the match occurred at in the string. We create a new result object that keeps track of that index, and then we tell that to please accept that into the consumer action. And so at that particular case, now we've found a way to pass back that object by reference back to the stream framework, and it'll use that to create this stream of result objects that it will basically return to the user. So that's essentially what we're doing for this point. There's lots more to this that we'll cover in more detail later, but I wanted to kind of give you the picture of how this all works. And the cool thing about search for phrase is we can reuse this for lots and lots of the other strategies that we have. So we can use it for the parallel stream strategy. We can use it for the parallel split iterator strategy. We can use it for the completable future strategies. It gets used all over the place. So it's a very helpful thing to have lying around. So that's essentially the implementation. That's the sequential streams version. I like it because it's very functional. It just does what it's about the what, not the how. Whereas the sequential loops version is about the how. We have to allocate stuff and have a loop and have if statements. But notice that there's no if statements here. Anything that would have been required with an if statement is addressed by the filter. So we can just read this thing from top to bottom. It's very canonical. We don't have to remember to allocate any memory. It's all managed for us by the collector that's created by toList. So it just removes a lot of the accidental complexities that would otherwise plague us if we were trying to do this with the more conventional object-oriented Java technique. Okay, so that's just an overview of this example. You'll be going through this stuff in the videos, and so you'll hopefully have a better idea of what we cover there, but it's also covered in there in some detail as well.